what is the vapor pressure of mercury at its normal boiling point? So there's a couple clues in that question that are important. The first one is the word normal. And so we have to know what boiling point really truly is. Boiling point by definition is the temperature at which a liquid's vapor pressure is equal to the atmospheric pressure. Right, so when we talked about boiling point, we said, I got this liquid, I keep it in a sealed container, I heat it up. As I heat it up, I'm putting more and more energy, kinetic energy, into the molecules. They start moving faster. Some of them break their intermolecular attractions. They escape the liquid and become part of the gas. I keep heating it up. Eventually, I reach an equilibrium where the amount of molecules that have evaporated start to come back down and rejoin the liquid because there's so many moles of gas. The pressure created by that gas causes some of those particles to move back into the liquid. That's the vapor pressure. Right, so if I have my sample in a container that's open to the atmosphere, instead of having a sealed container, instead of having a lid on that container, the atmosphere, the air around me, kind of acts as a lid, sort of. Because the molecules in the air around me are hitting down on the surface of that liquid with pressure, like holding it in. If you take water and you put it in a vacuum, it will start to boil at room temperature because there's no air holding it down. Right, so what happens with those water molecules on the surface of the liquid water? Each water molecule on the surface of the liquid water has some motion. It's moving around, but it probably has some hydrogen bonding attractions with the liquid molecules around it. But it has motion at room temperature. On average, they're moving around. Some of the fastest moving ones can break those attractions. But if they start to break their attractions with the water molecules around them and escape the surface of the liquid, and there's air, like nitrogen and oxygen from the atmosphere, air hitting down, it will bump into that water and just push it right back down into the liquid most of the time. So to get a liquid to boil, you have to move the molecules fast enough so that the number evaporating is large enough that it can overcome the air pressure from the atmosphere forcing it back down. So that's what boiling point is. So the vapor pressure, or the amount of pressure created by the water evaporating, has to be equal to the pressure forcing down on top of it by the atmosphere in order for it actually to boil and really escape the surface of the liquid at a fast rate. So normal boiling point means you're doing this at a normal pressure. And the normal pressure is 1 atmosphere. Right, so normal boiling point is the boiling point where you have normal or standard atmospheric pressure of 1 atmosphere around your liquid. So what vapor pressure does the liquid have to get to in order to boil? 1 atmosphere. The water or liquid has to get to whatever its vapor pressure has to get to whatever the atmospheric pressure is in order for it to boil. Right? So if I'm not talking about a normal boiling point, I'm just talking about boiling point, the vapor pressure that the liquid has to reach to boil will depend on what the atmospheric pressure is. If I go up into the mountains or if I apply a vacuum to my liquid, the boiling point will be lower than the normal boiling point because it doesn't take as much heat to get the vapor pressure to rise to half an atmosphere or 0.8 atmospheres. It takes less heat to do that than it takes to get to 1 atmosphere. But normal means 1 atmosphere. So I need my vapor pressure to reach 1 atmosphere, the same as the atmospheric pressure, in order to get my sample to boil. So what vapor pressure of mercury? really doesn't, in this question 12.85, it doesn't really matter that they're talking about mercury. They could be talking about any substance. What's the vapor pressure of the liquid substance? What vapor pressure does it have to reach in order to get to its normal boiling point? 1 atmosphere, right.